The world our students live in is shaped by technologies such as generative AI and concepts such as the metaverse, developments that simply didn't exist when their teachers were in school. But this shift is about more than just technology. It's also about culture, so it calls for a change in how educators approach education. In this address delivered to the Hong Kong Mathematics Education Conference 2025, Professor Frederick Leung Koon-shing invites us to reflect on a fundamental question. What role does mathematics education play in a rapidly changing world? Drawing on his extensive expertise, Professor Leung shares insights on how to keep mathematics education meaningful and relevant for today's generation.
I'm looking at some big ideas, big issues. As I wrote in my abstract, I don't know whether you read abstracts of my talk. The first line says that classroom teachers around the world, including those in Hong Kong, some of us are here, usually have their minds narrowly focused on their everyday teaching, which is understandable, right? We're teachers, we're paid to do it. But today I'm going to talk about something bigger, because I think as a professional teacher, I think we should have a bigger picture in mind. Right? Because the world that we're living in today is very different from the world when you and I were students. Right? So maybe some of the things that I said this morning, we've said, oh, what has that to do with mathematics education? But it depends on how you define mathematics education. Remember this? Familiar picture, right? We all went through this. What is this? Climate change, right? We experienced the hottest day, a few days ago, so the whole ecology seems to have changed. Where is it? Ukraine, right? So we are living in a world where wars are happening, geopolitics, climate change, worldwide health problems, global inequality, illegal and involuntary migration, ungoverned AI, misinformation, etc., etc. This is the world today. What's the classroom today like? This is the classroom today in Hong Kong. This is the classroom today in Ukraine. So it's business as usual, right? We're teaching a 20th century or even late 19th century curriculum, chalk and talk, endless exercise. Maybe now we're more advanced. We have DGS, dynamic geometry, but still a lot of exercise. Mathematics is treated as a skill to be imitated and a collection of facts to be memorized. I don't know how you feel. I feel this is just not right. The world, so much is happening. And in the classroom, it's business as usual. Now, is school education confronting this macro world challenges? Narrowly on mathematics education, is mathematics education relevant to the world today? Solving quadratic equation, what has that to do with all these global things that we are facing? Is mathematics relevant to our students? Does school math contribute to solving or at least understanding these global issues? What are we concerned about? As I said, we classroom teachers, we're all very concerned about everyday teaching. On the other hand, our government, or the government in many parts of the world, they are very interested in mathematics competition or in this global studies. In my introduction, you're told that I lead the PISA project in Hong Kong. So my objective of leading the PISA project is to find out the achievement of Hong Kong students, whether they're good or not. If they're not doing well, why is it the case? But actually, this TIMSS PISA, they are not competitions. They are research projects, as the goal of TIMSS said, to provide best policy relevant information to help improve math and science teaching and learning. In reality, it is treated as a rat race. This is an old news, 2008, in The Guardians in England. The topic is the Olympics of education. We're talking about teams. And then it said that it is it's a competition. Singapore, South Korea, they took home the medals, etc. Is that what is most important to our system, to our students? There are lots of criticism of this big projects like PISA and TIMSS. Some even argued, is this ranking of countries, is it methodologically sound? Are we not comparing apples with oranges and put them together and put a ranking? Are these international studies fair? Can international study ever be fair? The curriculum different, the contexts are so different. So is it meaningful to compare? So many countries, right, they said, oh, we want to be internationalized. We want to learn the best from other countries. But it's the so-called international standard or world-class standard. Is that something that we should aspire to? Is there an international standard? And if this is, should we aspire to this? I always say to teachers, especially those in mainland China, because in mainland China they want to be this expert teachers, right? And then they teach a very good class, and then they were even invited to teach their math lesson in another school and public demonstration. But I said that I will never aspire to be an expert teacher in that sense. I want to be a good teacher that teaches my students well. Because look at this assumption. You ask a teacher, in, say, a village, and then go to another village or a town to another town to demonstrate your teaching. He or she doesn't even know the students. How can she or she teach well? Are you saying that there's some teaching which is good irrespective of who you are teaching? I don't believe this. So I think as a teacher, I think what we should aspire to, what we should want to achieve is not that I become a famous teacher, I can teach well everywhere. I just want to be a teacher that teaches my students well because I know my students. So all these international studies, I don't know whether they're meaningful or not. Maybe they're meaningful, to raise the profile of a country, but they're not addressing any of these global issues that we've been talking about. Now, the changing world offers both challenges and opportunities. I think there are two forces that drive these changes. One is a philosophical force, and the other is a technological force. Now, in the interest of time, I won't elaborate here. We are in a postmodern world where we are skeptic about everything, everything subjective, relative. This, 19th, 20th century rationalism, is being put in doubt. Right? So the individual is a mere product as constructed by language, social factors, and so on. So what does that mean? Now, in the realm of mathematics education, in the 1980s, somehow, everything happened in that decade. We call this a socio-cultural turn. In 1984, for example, in HKMU, the International Congress of Mathematics Education, D'Ambrosio gave this keynote speech on ethno-mathematics. Ethno-mathematics is talking about there is not one mathematics. Different cultures produce different mathematics, and hence mathematics learning should be different in different cultures. Bruce talked about didactic contract, saying that teaching is not just, the teacher has some mathematics and then you transect it to the student, but it is an implied contract between the teacher and the student. So social and cultural factors matters a lot in math teaching and learning. And in 1988, HKMU 6 in Budapest, there's one-day program devoted totally to mathematics, education, and society. And in the same year, in PMU, Nunes' keynote speech about street mathematics. These students in Brazil, in the streets, their mathematics is totally different from the mathematics they learn in school. Right? And education system in mathematics devoted a whole issue to mathematics and culture. So somehow in the 1980s, there is this big change in orientation, saying that success and failure in math education is not just due to things that happen in the classroom. It's not just a psychological approach. It can be explained a lot by social and cultural factors. And also there's a change in research methodology. Those in education research will know, changing from this quantitative, modernist approach to an interpretive, phenomenological paradigm. So 1980's conclusion is that both mathematics itself and mathematics teaching and learning are socio-cultural products, and learning depends on factors within and beyond instructional activities in the classroom. And what is the social impact of issues on math education? I just use one example. Inequity. UNESCO said that inequity in education is the most serious problem in education worldwide. Right? There's a lot of causes. Right? For example, around the world, 250 million, or 17% of the world's children, adolescents, are out of school. In Hong Kong, we're really fortunate. Nearly 99% of our school-age students are in school. But do you know that 17% of the world population, school-age students, they don't even have a chance of schooling? The proportion is much larger in developed countries. For example, 31% in Sub-Saharan Africa, 21% in Central Asia. So is education and our classroom mathematics teaching in particular, is it addressing this global issue of inequity? In the HKMU just passed in Sydney, we grant this Frontal Award, which is the highest award in math education, to O. Skosmos. Right? His field of study is critical mathematics education. So he published a very famous book. Right? So this book addresses issues with respect to racism, oppression, erosion of democracy, etc. Right? It explores relations between mathematics, ethics, crisis, and critique. Right? Have we ever thought of mathematics having this dimension? And then HKMI, the International Commission on Mathematics Instruction, we launched this HKMI study. The latest study that we launched is called Mathematics Education and the Sociological, also tackling some of these social, political, ecological issues, such as climate change, poverty, etc. Right. So there is this whole dimension of mathematics education that we, maybe as a classroom teacher, we don't have the time or the energy to think about. But I think these are very important questions. Because we are not just teaching mathematics. We are teaching students. I remember I was in a meeting, and then people introduced themselves, and then people said, well, what's your profession? And then many people said, 我教書嘅. And then one person said, 我係教學生嘅. Do you teach mathematics or do you teach students? That makes a lot of sense. Just give you one example. Of course, as a math teacher, I always want students to like mathematics. But if there's a student who devotes all his time to mathematics, not interested in anything else, am I a successful mathematics teacher? So I think these are things that we should think about. So the implication of this social-cultural perspective is that classroom teaching and also at a policy level, change in policy need to take cultural and social factor into consideration. What should we teach? How should we teach? How should we measure and interpret student achievement? We teach percentages, right? We teach what problem, there's a box there, 20 apples, 10 oranges, what percentage? Right? Or have we considered using examples such as this to talk about percentage? How much percent of school children are out of school? Right? So, if we just suggest drastic changes of practices, policy, without due consideration of the nature of those studies and also the cultural differences, it can be misleading or even harmful. I always use this example. Some states in America, they imported Singaporean textbooks because Singapore did so well in TIMSS and PISA. I was telling this American friends, no, it doesn't work. Because you can import Singaporean textbooks, but you cannot import Singaporean culture. And Singaporean textbook work only in the Singaporean culture. So if we introduce these drastic changes without due consideration of the cultural difference, it can be misleading or even harmful. We should critically examine our own culture in light of new demands of the world, but we should not change our cultural value just to suit the modern world, or so that our students score better in this international studies. I was talking to some Shanghai friends, teachers. Shanghai did very well in PISA, right? World number 1. And then Shanghai schools are adopting the PISA curriculum. Well, maybe a good thing. If after consideration, I think PISA is a good thing, then maybe it's good. But if you just want to score well in PISA and then you change the curriculum, is it something that we should aim at? Right? Is it something which is very good in our own culture, which does not suit TIMSS and PISA? Should we insist that instead of training our students in TIMSS and PISA and score well and tell a good story about Hong Kong and about Shanghai? Also, should math education be addressing some of these issues in society in which our students live? Right? So this is what I call the philosophical force. Let me turn to the technological force, because I think that's something that I'm expected to talk about in a conference like this. The first thing, of course, everybody is talking about STEM. Right? So here are a number of quotations from very important people saying that in this technological world, STEM education is so important. A few words about STEM. We all know that STEM is not a subject. It's not even a cluster of 4 subjects. Right? It is an approach to education. The characteristic of STEM education is that it's interdisciplinary, collaborative, technologically driven, promotes inquiry-based, active learning, tackles real-world problems. Now, these characteristics are exactly those attributes that we want to inculcate in our students. So I think STEM education has a very important role to play. And mathematics has a very important role to play in STEM, because mathematics, all people say, is the foundation of STEM. So I always like this Lo Huyun's paper. This, mathematics, is the key and one component, the key to STEM. Right? But what is mathematics? When we say mathematics is the key or the foundation of STEM, what do we mean by mathematics? Again, without elaboration, I would say that the essence of mathematics lies in its process. It's not just about algebra, geometry, or arithmetic. It's about how we approach algebra, geometry, and arithmetic. It's not just calculation. It's about investigation, problem-solving, justification. It's about abstraction. It's about rigorous thinking, expression, clear thinking, and communication. So when we say mathematics is the foundation of STEM, I say the process of mathematics is the foundation of living for individual and for the healthy growth of society. So what are the implications if you hold this view? How should mathematics be taught in order to inculcate in students these unique qualities? My view is that we should stress the process rather than the contents of mathematics. So some people are talking about a curriculum based on verbs rather than based on nouns. What does this mean? A curriculum based on nouns is, okay, algebra, you have equation, linear equation, blah, blah. So these are all nouns. But we should instead stress a curriculum based on verbs to investigate, to explore, to justify, to reason, etc. Right? So the way to arrive at the answers to a problem is much more important than the answer itself. We all know this, right? You give a student for a student to solve. They find an answer. Do you not already know the answer? You already know the answer, right? So why are you interested in their answer? So we are interested in the way they arrive at the answer. And this is the thing that we should stress in our teaching. I think one important sphere of mathematics is modeling, because it is exactly, this process of mathematical modeling, when you have a real-life problem, you formulate a approach to solve it. This is the essence of mathematics. Take COVID, for example. Well, we talk about number of confirmed cases, right? What do you mean by number of cases? We have averages. We have moving averages, right? So by moving averages, how many days? 1 day, of course, 1 day is not a moving average. Right? Is 3 days good? 7 days or 10? So which is a good indicator of the trend of the number of cases? This is a really good topic to discuss with your student, right? Because we are setting a model to understand the situation, the number of cases falling or increasing. And what is false negative, false positive? We all use this term, right? So it's just our type 1 and type 2 error. Have we tried to link type 1, type 2 error to the false positive, false negative that students are experiencing day and day during the COVID? And we're talking about vaccine efficacy. What is vaccine efficacy? There was one point that say that in one vaccine, they said the efficacy is 53%. 53%? So do you mean if you take the vaccine, 53% of people get protected and then 47% do not get protected? So this is totally different, totally wrong conception. They don't have this conditional probability idea. Now, how many of us math teachers relate all this to, what students are experiencing? Right? So this effectiveness, this is the wrong thing. I want to say a few words about generative AI, ChatGPT. We're using it so often. So in my spare time, I would ask ChatGPT to solve some problems and see how. And then I think last year, early on, I asked ChatGPT, I think it's 3.5, to ask them, prove that square root of 3 is irrational. I don't ask square root 2 because there's a lot of square root 2 in the literature. And then ChatGPT 3.5 gave a perfect answer. And then I asked ChatGPT, prove that square root 4 is irrational. And then ChatGPT 3.5 said, oh, square root 4 is rational. And then I asked ChatGPT 3.5 this question, why can you not use the way to prove square root 3 irrational to prove that square root 4 is irrational? And then I was very disappointed because ChatGPT 3.6 said that, I'm sorry. He said, I'm sorry. He said, square root 4 is indeed irrational. So I am very disappointed. But then a few weeks later, come 4.0, and then I do the same thing. It learned, right? It gave a perfect answer. So I tried this time square root 8, proof square root 8 is irrational. Can you give a perfect proof, with explanation? And then proof square root 9 is irrational. He said that actually square root 9 is not irrational. In fact, square root 9 is 0 to 3 and 3. And then I asked the same question, why can I not use this method to prove? And then it gives a totally perfect answer, right? With conclusion, etc. Now, why am I showing this example? I was asking myself, if ChatGPT can do it so perfectly, how should I teach my student? What should I teach my student? Is it still very important to talk about, proving all these things? Actually, the impact of generative AI on math teaching and assessment, they're multifaceted. So, generative AI in general, I think, facilitates personalized learning and tutoring. We all know this, right? With a big class, it's very difficult for you to cater to the needs of individual student. But with AI, they can provide instant step-by-step explanation that tailor to individual needs. So it's a very powerful platform. It enhanced engagement and visualization. Right? Dynamic geometry is just one of them, but there are lots of tools that help us to visualize, help students to be engaged. It provides students with a lot of support. I need to, because I attended a conference in Europe, and then I need to write a report for the conference. So I just asked ChatGPT to do it for me, and and then of course I have to change a little bit. So lots of, even if you're teaching a certain topic, I think ChatGPT can help a lot. Of course, you have to have your own input. But of course, to do this, teachers need training to effectively engage AI tools and understand the limitation and guide students in ethics and productive use. And there's also this change in assessment practice. Let's talk about PISA, for example. PISA is now using this adaptive testing strategy. That is, students taking the PISA, they don't take the same items. They will take a number of items, and then depending on the performance, they will give them other items that suit their ability. And they have a way to equate their ability. Now, the good thing is that because if they're too difficult, the items are difficult, or too easy, you can't measure the ability of the student well. So AI is changing this a lot. Of course, there are a lot of problems. Integrity concerns, right? Plagiarism. If you give a problem to a student, how can I find out whether he does it or he asks ChatGPT to do it? There are equity and access issues. Now, of course, generative AI can bridge the gap. We can learn everywhere, anywhere, but there is this technological gap. More importantly, now that ChatGPT can solve nearly all problems, how should we change the curriculum that we're teaching? I just want to mention one thing. We should educate our students to be able to make critical and informed judgment on the information that they encounter. So, for example, I can imagine you give them a problem, ask them to use DeepSeek or ChatGPT to do it, and then ask them to judge the correctness of the answer. rather than these technical issues of how to solve that problem. If I look back at this whole issue, I think the biggest challenge that is facing mathematics today is the issue of relevance. Relevance of mathematics to society and to the individual. Now, of course, in Hong Kong, in mainland China, maybe this relevant issue is not that important because the most relevant thing is examination. But if we take away examination, why do students have to learn mathematics? What is mathematics contributing to this world? How is mathematics relevant? So when math is taught as a business as usual manner, it's hard to expect students to find mathematics relevant. Now, of course, I don't expect students at their level to be able to solve global issues facing the world today. At best, it can only just provide foundation for them in the future. But we should at least equip them to be able to understand the mathematics behind some of these global issues. Take global warming. This is a mathematical model that describes the effects of mathematical model. Can we, introduce some of them so that even if they can't solve this problem, they understand what it involves through the lens of mathematics? But most importantly, mathematics education to contribute to the growth of students as a human being. Independent, logical, critical thinking is one important attribute of human being. So, it boils down to this question of what purposes does mathematics education serve? I mentioned at the beginning that some of you may find this talk, what has that to do with mathematics education? Well, it depends on what you mean by mathematics. Actually, most of the things that students learn in the classroom has no real-world application. And the contribution of math in addressing the world problem that I mentioned at the beginning is at best indirect. But mathematics serves the important function of facilitating understanding of the issue. And also, the advance of AI forces us to reflect on what mathematics to teach and how to teach it. More importantly, mathematics helps develop students with facilities of logical, independent thinking, which is so important for living and for life. In this world of fake news, I think this is especially important. Just scrutinize every word Donald Trump says. Are we able to independently, critically look at the truthfulness of these statements? This is what we want to help our students to do. But of course, in order for students to be educated this way, students must first find mathematics lessons to be stimulating and relevant. And that falls on the shoulder of teachers. We have to make mathematics relevant, interesting, in order to inculcate these facilities of critical thinking, independent thinking, and logical thinking. Thank you very much.